Students, here I have different types of quadrilaterals prepared on drawing sheets. Okay?
Yes.
Now I'm going to ask you a set of questions related to the properties of quadrilaterals and you have to answer them. Understood? Here, you take this one. Now, I have given you different types of quadrilaterals. You have to observe those figures properly and I am going to ask you 3 questions and you have to answer those questions properly. The 3 questions are: what can you say about its opposite sides? Second, what can you say about its opposite angles? And third, what can you say about its diagonals? Okay? Now observe the figure, analyze it and answer the questions.
Both pairs of opposite sides are parallel and congruent. Opposite angles are congruent. Diagonals bisect each other.
Very good, correct.
Opposite sides are congruent. All angles are right angles. Diagonals are congruent. Diagonals bisect each other.
Now you tell me.
All sides are congruent. Opposite angles are congruent. Diagonals are perpendicular bisectors of each other. And diagonals bisect opposite angles.
Okay, now you tell me.
All sides are congruent. All angles are congruent. Diagonals are congruent and perpendicular bisectors of each other. And diagonals bisect opposite angles.
One pair of opposite sides is parallel.
Adjacent sides are congruent. The longer diagonal bisects the shorter diagonal. One pair of opposite angles is congruent. A rectangle, a rhombus, and a square are all parallelograms.
You are familiar with the properties of the quadrilaterals. But now we will see how to logically prove them. Okay? Let's see. Opposite sides and opposite angles of a parallelogram are congruent. Let me explain you how it is. Give me any one of the parallelogram. Yes. Now see, this is a parallelogram. Now I am going to fold this paper on its diagonal. Now see, here due to this fold, we can see 2 triangles. Is that correct? Yes, okay. Now using this figure, let's understand how we can prove this. Okay? So now, what's our first theorem? Opposite sides and opposite angles of a parallelogram are congruent. And now, we are going to prove this. Now to prove that, I am going to draw this figure. Now this is our parallelogram PUNE and its diagonal is UE on which we have folded this paper. Now here the quadrilateral PUNE is a parallelogram and in this PU is parallel to EN and PE is parallel to UN. Now what do we need to prove in this? Line segment PU is congruent to line segment EN. Line segment PE is congruent to line segment UN and angle EPU congruent to angle UNE and angle PUN congruent to angle PEN. Now due to the fold on this paper, we have got these 2 triangles, that is triangle EPU and triangle UNE. Now here angle PUE is congruent to angle UEN and angle PEU is congruent to angle EUN because as PU is parallel to EN and UE is the transversal, these are the alternate angles. Now also, side EU is congruent to side UE because it's the common side. Therefore, triangle EPU is congruent to triangle UNE by ASA congruence test. Therefore, it gives us side PU congruent to side EN and side PE congruent to side UN. Therefore, angle EPU is congruent to angle UNE because these are the angles from two congruent triangles. Now, let's understand how we can show angle PUN is congruent to angle PEN. And to prove this, tell me which two triangles we will have to use?
We need to draw diagonal PN.
Once we prove that triangle PUN is congruent to triangle PEN, we can conclude that angle PUN is congruent to angle PEN using congruent triangle properties.
We are going to discuss the second property of the parallelograms. The diagonals of a parallelogram bisect each other. Now let's understand this using this figure. Now here, quadrilateral BHAR is a parallelogram. Now what we need to prove is diagonals BA and RH bisect each other at point T. Also, line segment BT is congruent to line segment AT and line segment RT is congruent to line segment HT. Now to prove this, which two triangles we should consider? Tell me that. Yes, tell me.
In triangles BTH and triangle RTA, angle TBH is congruent to angle TAR. Side BH is congruent to side RA. And angle BHT is congruent to angle ART. Therefore, triangle BTH is congruent to triangle ATR by ASA congruence. Therefore, line segment BT is congruent to line segment AT. Therefore, line segment RT is congruent to line segment HT.
Perfect. Now let's solve few examples using these concepts. Okay. Now let me give you few examples. Solve those in your notebooks. Come on. Okay. This is the first example. In parallelogram ABCD, the adjacent angles are in the ratio 2:3. Now find the measures of all the angles. Okay, try it out.
Solution. In ABCD, let angle A is equal to 2x and angle B is equal to 3x. Angle A plus angle B is equal to 180 degrees. (2x plus 3x is equal to 180 degrees. Therefore, 5x is equal to 180 degrees. X is equal to 180 divided by 5 is equal to 36 degrees. Therefore, angle A is equal to 72 degrees. Angle B is equal to 108 degrees. Angle C is equal to 72 degrees. And angle D is equal to 108 degrees.
Excellent, that is correct. Okay, now I'll give you the second example. Okay, now quadrilateral SOFA A is a parallelogram in which OF is equal to 5 minus 3y, SA is equal to 2y plus 15. Then find the length of SA.
Since opposite sides of a parallelogram are congruent, OF is equal to SA. Therefore, 5 minus 3y is equal to 2y plus 15. Therefore, 5 minus 15 is equal to 2y plus 3y. Therefore, minus 10 is equal to 5y. Therefore, y is equal to minus 2. Therefore, SA is equal to 2y plus 15 is equal to 2 into minus 2 plus 15 is equal to minus 4 plus 15. Therefore, SA is equal to 11.
Oh, perfect! Come on, I'm giving you the third example now. In parallelogram LEAR, diagonals LA and ER intersect at point N. Now given is LN is equal to 2x, NA is equal to 9 minus x and EN is equal to 5y minus 11 and NR is equal to 2y plus 1. Now find the length of the diagonals.
Since the diagonals of a parallelogram bisect each other, Ln is equal to Na. Therefore, 2x is equal to 9 minus x. X is equal to 9 upon 3. Hence, x is equal to 3. Hence, La is equal to Ln plus Na is equal to 2 into 3 plus 9 minus 3 is equal to 6 plus 9 minus 3. La is equal to 12. En is equal to Nr. Therefore, 5y minus 11 is equal to 2y plus 1. Hence, 3y is equal to 12. Hence, y is equal to 4. Therefore, ER is equal to 5 into 4 minus 11 plus 2 into 4 plus 1. Hence, 20 minus 11 plus 8 plus 1. Hence, ER is equal to 18. Hence, LA is equal to 12 and ER is equal to 18.
Very good. That is perfect. And Tejas, the fourth example is for you. Okay. In parallelogram BEST, given is BE equal to 2x, ST equal to 18, ES equal to 2y plus 5, TB equal to y plus 9. Then find the perimeter of BEST.
Since opposite sides of a parallelogram are congruent, BE is equal to ST. Therefore, 2x is equal to 18. Therefore, x is equal to 9. Therefore, BE is equal to 18. ES is equal to BT. 2y plus 5 is equal to y plus 9. Therefore, y is equal to 4. Therefore, ES is equal to 2y plus 5 is equal to 2 into 4 plus 5 is equal to 8 plus 5. Therefore, ES is equal to 13. Perimeter of BEST is equal to BE plus ES plus ST plus TB is equal to 18 plus 13 plus 18 plus 13 is equal to 62. Perimeter of BEST is equal to 62.
Okay, excellent. Very well. Now all of you, have you understood the properties perfectly? Now solve such examples in your home also so that you will understand this correctly. Will that work? Okay, let's meet again now. What did we learn? Properties of different quadrilaterals, parallelogram, rectangle, rhombus, square, trapezium and kite. Proof of the theorem that opposite sides and angles of a parallelogram are congruent. Proof that the diagonals of a parallelogram bisect each other. Application of these properties in problem solving. Exercise. In parallelogram PUNE, given is angle P equal to 70 degree, angle U equal to 110 degree, find angle N and angle E. In quadrilateral ABCD, given is AB parallel to CD, BC parallel to DA, AB equal to 5 units, BC equal to 11 units, find its perimeter. In parallelogram PQRS, diagonals intersect at point M. Given is PM 6 units, QM 8 units, PQ 10 units. Prove that PQRS is a rhombus. The adjacent angles of a parallelogram are in the ratio 5:4. Find the measures of all its angles.